Hi students, this is Mrs. Laybourne and this is section 8.3, 0 and negative exponents. If we look for a pattern, 10 cubed is equal to 1,000. And 10 squared is just one less factor of 10, or 1,000 divided by 10, and so we could say it's equal to 100. 10 to the first is 10. And so likewise then, 10 to the 0 would be 1. If we divide 10 by 10, we get 1. 10 to the negative first would be 1/10, either as a fraction or a decimal. And 10 to the negative second would be 1/10 squared, which would be 1/100th. And I'm not sure why it stopped working here. There we go. So and this would work for any base. It wouldn't have to be 10. It could be base 6, could be base x. It could be anything. So for that regard then, -1/2 or any base here, except for 0, we don't have 0 to the 0 power. If we have it to the 0 power, it's defined to be 1. And a number like -5 to the -4th means it's -5 to the 4th. -4th, we take the reciprocal and we have 1/-5 to the 4th. So that negative exponent does not mean that anything is going to be negative. It means that we're taking a reciprocal, just like it did for 10 to the negative second. It's the reciprocal of 10 squared. And so we could simplify this now and say that it's 1/625. Another example would be if we have 1/6 to the negative second. Now it means the reciprocal, and since it's already in the denominator, its reciprocal would be in the numerator, and so it would be equal to 6 squared, or 36. So if the negative exponent is in the denominator, if it moves to the numerator, it becomes a positive exponent. Or if it's a negative exponent in the numerator, it moves to the denominator and it becomes a positive exponent. I'm going to put up a couple more problems. I'd like you to do them. Press pause and then come back. So the first one, we have the fraction 5/3 raised to the -3rd. So that will be your first problem. Second one is 13 to the 16th times 13 to the -14th. Your third problem is -2 raised to the -4, and then that quantity raised to the second. And then your fourth problem will be 10 to the second divided by 10 to the -3rd. Again, press pause, and when you have finished, then come back. Okay, so this problem would be 5 to the -3rd over 3 to the -3rd. Again, I need to take the reciprocal, and so I'd have the 5 to the 3rd in the denominator and the 3 to the 3rd in the numerator, and I could say that it's equal to 27 over 125. For this problem, I keep the base the same. I can add my exponents just as I did when they were both positive, and I have 13 squared, or 169. For this problem, I can apply my rule, so I can keep the base the same. So the base is -2, and -4 raised to the second would be on -8 as an exponent. And because we don't like to keep negative exponents, it would be the reciprocal, so it's 1 over -2 rather, to the 8th power. And for this one, I could do it a couple ways. I could move the 10 to the -3rd to the numerator, because I'm taking its reciprocal, or I could just simply divide the 2. My base is 10. I start where I have a positive number of, or where I have more factors of 10, and here I have the 2. So 2 minus a -3 would be 10 to the 5th. And then, of course, you could write that as a decimal. Okay, so then we can, let me get to another page, and I will give you a few more problems. Just one second. Okay, for my next example, I have now the quantity 5x squared y to the -3 z, and that's all raised to the 4th. So I can write this quantity separately as factors, and I can say that it's equal to 5 to the 4th, x squared raised to the 4th, y to the -3rd raised to the 4th, and z to the 4th. And then I could simplify each part. So 5 to the 4th would give me 625. X squared raised to the 4th is x to the 8th. Y to the -3rd raised to the 4th. I multiply my exponents, would be -12, and z to the 4th. And again, we're going to want to write our answers always so we have positive exponents. So everything, or each factor, could stay in its present location except for the y to the -12. And for that one, again, the negative sign says take the reciprocal. So now the y is in the denominator, and now to a positive 12 as an exponent. I'll do one more with you, and that is 4m to the -2nd n p cubed divided by 12m squared n to the -5th p. So again, I could start to do my division, well, 4 divided by 12 is 1/3. I don't need to write the 1. M to the negative second divided by m to the second. It's easier if I start where I have a larger exponent, and so I'll keep the m in the denominator, and it's 2 minus a negative 2. The n's, I have a larger exponent in the numerator, so it's n, and it's 1 minus a negative 5. And for the p's, I have a larger exponent in the numerator, and so it's p to the third minus 1. And so now I can say n to the sixth, p to the second, all over 3m to the fourth. Another approach would be if I were to see if I can get my page to move down. Whoops. It doesn't want to, whoops, there, now move too far. I could move this m to the negative second to the denominator right away, and I could move the n to the negative fifth, take its reciprocal, and move it to the numerator, and then I wouldn't necessarily have to divide, but I could multiply those terms. I'm going to write down 2 problems for you to do, and then you can check your answer with me in just a minute. So 2r squared t, all raised to the negative third, times rs t to the fourth, divided by 6 r to the sixth s to the negative third. And the second problem would be 3m to the negative second n cubed, all raised to the third power. So press pause, do those 2 problems, and then come back. Okay, so for this one, I'll try another approach. Since this is a negative exponent, I could just move it all to the denominator with a positive exponent, 2r squared t, all to the third. The rs t to the fourth, they all have a positive exponent, so I can leave them alone. The 6 is with a positive exponent. I'll leave it in the denominator along with the r to the sixth. And the s to the negative third, since its exponent is negative, I'll take its reciprocal and move it up here. And then I could multiply and my like terms, and I'd have r s to the fourth t to the fourth divided by 2 to the third would be 8. R squared raised to the third is r to the sixth. And then when I multiply by this r to the sixth, I'd have r to the 12th. And t raised to the third would be t to the third. And then we have times 6. So my final answer, I have 1 r here, and I have 12 of them there. So now that gives me r to the 11th in the denominator, 12 minus 1. I'd only have the s's in the numerator, so I'll say s to the fourth. T's, I have 4 of them here, 3 there, so it leaves me 1 in the numerator. And then I have a 48 in the denominator. And so in the end, I have s to the fourth t over 48 r to the 11th. Again, there's several different ways to approach the problem. This is just one. But if you ended up with this answer, then your work should be fine, or you can check with me tomorrow. For this problem, I'm going to take each of the factors and raise them to the third. It's so easy to forget the coefficient. So I need 3 to the third, I need m to the negative second to the third, and I need n to the third raised to the third. That's going to give me 27. Since this is a negative 6, I can put it in the denominator, take its reciprocal, and it's m to the sixth. And the n is going to be to the 3 times 3, or 9th power. The n and m are different, so I can leave my answer in that form. I hope this has helped you, and I will see you in class soon. Bye-bye.